Hello, welcome back. Let's continue where we left off in our development of the GPIO driver. I'm going to make a copy of our last project so that we continue from there. I'm going to copy this. This is the folder for the project. I'll copy and paste and call this number 2. I'm going to upload the projects to the video. I don't want you to just have one project with everything complete. I think it's much more complicated or difficult to understand if you are using it as reference. So when we build, we're going to create a copy of the old project and just continue. So in this lesson, we're going to add the addresses, the base address for the other GPIO ports. Currently, we've just written the code for GPIO port A, but our microcontroller gives us port B, C, D, E, H, and A. So we need to include those. So I'm going to close the old project and open this new one. Right, so here we are. So what we have to do, like we did for GPIO A, we got the base address of GPIO A over here, and the base address is the AHP1 peripheral base plus 0, 0. This is the offset. So we need to go to our datasheet to get the base address of GPIO B, C, and D. So I'm gonna, I'll jump to the datasheet first. So this is my datasheet, and you know how to open it. You come to books. This is where the program starts. You come to books, and then you click here to open your datasheet. Right. So GPIO port B, this is it. So I'm just going to copy this. This is for port B. And just like port A, you can tell that we simply need to add this value to the AHP1 peripheral base, because AHP1, because we know this is AHP1 peripheral base is this plus this, and our GPIO B, as we see in the datasheet, GPIO B here, the value here is this plus just this bit, the offset. So we're just gonna get the offset and add it. Right, so I'm gonna do define GPIO B underscore base, and this I'm simply going to copy and paste this here. Copy this, paste this over here, right, and then I'll clean this, and then I'm just going to paste this and rename. So this becomes C, D, E, H. There is no F, A, B, C, D, E, H. Okay, so now let's just get the offsets. So let's check for GPIO port C. Port C starts over here, so we know the offset is this. So I'm going to copy this. Right. The next one, D. Port D. This is the offset. The one after this is E. This is the offset. And then finally we have H. Where is it? GPIO H. Okay, this is H. This is the offset for H. Right, so now we have the base addresses. Now we have to create GPIO A. We have to create GPIO A like we did for GPIO. We have to create GPIO A B C D E H like we did for GPIO A over here. We typecast it to a pointer of our structure type. So I'm just gonna copy this, then paste it over here. I rename this to B, and then I'm gonna rename this to B, and then I'm going to paste the number of times for the rest. So this becomes C D E H, and then we change over here C D E and then H like this. Right, okay, yeah, we are set actually, so we can try it out. So what I'm gonna do, I'm also going to create a symbolic name for enabling the various ports when we go to the AHP1 enable register, like this 0x01 here. I'm going to create a symbolic name for it so that we don't always have to type it. So I'll say define GPIO A EN, and this is essentially moving one, shifting one to bit number 0, and then we're going to have define GPIO B EN. This is shifting one to bit number 1 in the AHP1 enable register, and this, the next one is define GPIO C EN, this bit 2, so then define GPIO D EN, this bit 3, and then define GPIO E EN, this is bit 4, and then define GPIO H EN, this is bit number 7. Remember, don't write 5 here by mistake, number 7. So if you check the AHP1 register, you realize that these symbolic names corresponds to the bits that are required to enable these GPIO ports. So how about we enable GPIO port B as well? Right, so in our previous lesson we enabled just GPIO port A where our LED is. I'm gonna come over here and then just replace this constant with a symbolic name we created. To enable port B as well, I'm simply going to add this vertical line, this an OR operator, and then I'm going to include GPIO port B here. Right, just by doing this we would have port B enabled as well. Now I'm going to set port B pin 5, PB5. I'm going to set that as output as well. To do that, I'm simply going to do GPIO B this time, and then I'll access the mode register, and then I'll use the same constant, mode 5 output, meaning set pin 5 to output. And once that is done, I'm going to blink, I'm going to toggle GPIO port B as well, just like I'm toggling the LED here. This is assuming an LED is connected to port B. So you can connect an LED to your GPIO port B, but we can verify this in the debug view, so you need not worry. So GPIO B over here, I'll say ODR. I'll use the same toggle operator, and then I'll say LED pin like this. Right, we are done. So now let's test it out. I'll click here to build. I'll click here to download onto my board. interesting. I've got to set my debugger. I don't know why that is. ST-Link debugger, settings, flash download, reset and run, OK, and then OK. Click here to download onto my board. It's downloaded successfully. We already know the LED is blinking because we tested that already in the previous lesson. Now let's see if our PB5 is also toggling. I'm gonna click here to go to the debugger. Okay. And once this opens, I'm gonna come to under peripheral. I'm going to come to peripheral and then system viewer. And then I'll come to GPIO and then I'll come to port B. I'll click and it would open over here. Over here, I can observe the changes that goes on in all of my registers. What we are toggling is the output data register. That is how the light blinks. Basically, we write into this register. So I'm going to expand this and I'm going to click here to run my code. Click to run. And as you can see, ODR5 is toggling on, off, just like we are toggling it. And we can verify PA5 as well. So often, if you are trying your GPIO and you don't have an LED to test with, you can test the firmware just by making sure it's working here. If it's working here, it means the software is fine. I'll come over here and then I'll just show you the same thing happening in GPIO port A. I'm gonna pull out port A. I've pulled it out. I'm going to just resize it a bit. Okay, so we have port A pin 5 here and port B pin 5. I'm gonna click to run, and as you can see, they are both toggling. Right, so this is it. This shows that our GPIO driver is working thus far. So I'll leave it up to you to test out the other ports. So far we've tested just port A and port B. You can test the rest and see how it goes. That's all there is for this lesson, and I'll see you in the next lesson. Have a nice day.